Okay, so we're going to be talking about valence and ionic compounds. And so you should have your handout and you should also have your best friend because that's going to be really, really, really important. And so the first thing that we're going to do is just to be able to determine the number of valence electrons in the elements. And then we're going to be predicting the ionic charge. And so when we look at these elements, what I want you to do is look at this table. And we're going to start making some connections between the elements, the number of total electrons, the number of valence electrons, and the charge that they form. So when we look at this, we're going to go to the very first element. Let's see if I can do this. The very first element is hydrogen. So if I come to the periodic table and I see hydrogen, what group is hydrogen in? So hydrogen is in group 1A. So what I want you to do is on your table, just make a new little column, right? And we're going to add that and we're going to make that the group. So hydrogen is in 1A. What is helium in? We find helium on the periodic table. It's in group 8A. And we're going to keep going down and doing this. So pause it here and fill that out for all of them. I'm going to do it as well. 1A, 2A, 3A, 4A, 5A, and what you'll see is we're all in the main group elements. 6A, 7A, and then it's going to start over. So we got 8A, and then we start over and we go to 1A, 2A, 3A, 4A, 5A, and because they're all A's, they're all main group elements. 7A, 7A, 8A, 1A, 2A. Okay, so as we kind of look at these, we need to start to see some important bits of information. We can get the total number of electrons in any given atom because we know the atomic number. Because the atomic number, which is our number of protons, is equal to our number of electrons for an atom, not for an ion, but for an atom. So if you're in group 1, all you do, let's see if I can erase, oh, here. Okay, so if I look at hydrogen, here's my hydrogen. This 1 up here is the atomic number. So that means I have 1 proton and 1 electron in the neutral atom. And so when we look at that, what we can say is not only does hydrogen have 1 valence electron, but anything that's in this column here in group 1A, anything has 1 valence electron. So if I go and find any of these columns that have elements in group 1A, what I'm going to see is, so that's 1A, got to find another 1A, right? And then another 1A and another 1A. So what do you see in common with all of these 1As? That regardless of the total number of electrons in the atom, every single element in group 1A has 1 valence electron. So it's 1 electron in that outer valence shell. And so the question is, if you have an atom that has 1 valence electron, what does it want to do? It wants to look like one of the noble gases. So let's pick, for example, sodium right here. So here's sodium, and on here, this one is sodium, right? So what is sodium going to do? It has 1 valence electron. It can do one of 2 things. It wants to get to 8. So if it loses 1, then it drops down a principal energy level, and go and find on the periodic table what element has 1 less electron. Well, sodium has 11. So then I'm going to go to one that has 10. So if it loses 1, it's going to look like neon. So that's one thing that it could do. It could lose 1 valence electron, and it would look like neon. Or on the other hand, what it could do is if it were sodium, and let's see how many it would have to gain. Have to gain 1, 2, 3, 4, 5, 6, 7. It would have to gain 7 to look like argon. That's a lot of work. And remember I said in class, elements are lazy. They're not going to do work that they don't have to do. So sodium is going to do the easy thing, and it's going to lose 1 valence electron. When it loses a valence electron, the charge on the ion that is formed, got to think about this. Okay, if we have sodium, let me get a pen. If we have sodium, the neutral atom has how many valence electrons? Well, let's do this. How many total electrons? It has 11 total electrons. And if it's a sodium atom, then that means it must have 11 protons. So now, you just told me, well, we just said that the sodium atom is going to turn into a sodium ion to get that complete octet. So to get that complete octet, what it's going to do is it's going to lose 1 valence electron. That's what we said right here. We're going to lose 1 valence electron. So here we go, losing 1 valence electron. If we had 11 and we lose 1, now we only have 10 electrons. We still have 11 protons, but we only have 10 electrons. So out of those original 11 electrons, one of those electrons was a valence electron. The other 10 electrons were inner electrons. They were closer to the nucleus, right? As you get farther and farther away, we finally get to the valence electrons. The valence electrons are the ones that are the farthest from the nucleus. So if you had that sodium atom, right, and we remember in that first principal energy level, we can only have 2 electrons. Then we get the next principal energy level, and it can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. And then sodium's in the third period here. So it's in the third principal energy level, and it's got this 1 little old electron right there. So if sodium loses its 1 valence electron, so I'm going to get rid of it. There it goes. It loses that outer valence shell. Now, what's in the outer valence shell of the sodium ion? So the sodium ion is what we're looking at down here, where it's lost 1 electron. So now it has, if I can move this, maybe, there we go. It has 8 valence electrons and 2 inner electrons. It's just the shell that those electrons are in has changed, right? Now the one lower is the outer valence shell because you've lost the outer one. Okay, so now we talked about the sodium atom and we talked about the sodium ion. So what I want to know is this sodium ion, what's its charge, right? So if I had 11 positive charges in the atom, and then 11 negative charges, which is the electrons. So the positive is the proton, the negative is the electron. If I have 11 pluses and 11 minuses, my net charge is 0 for the atom. And we know that atoms are supposed to be neutral. But when I lose that 1 valence electron and I become the ion, now that sodium ion has 11 positives and only 10 negatives. So positive 11, negative 10 gives me a net of positive 1. So when I look at sodium ion, I give it this symbol. I put the symbol with the positive sign up high. And so this is just kind of all of the concepts that you have to understand about what happens when atoms convert to ions. They're always going to have some number of valence electrons that is not equal to 8. It's always going to be less than 8. And they're going to do something in order to get 8 valence electrons. Because if you look at this, how many valence electrons are in the ion formed? It doesn't matter what ion is formed. How many valence electrons do we have? We always make 8 until, oh my gosh, we get to these that have 2. Why is that okay? Well, if you come down here and we look at our example, right? What if we lost, see if I can find the eraser again. We lost this outer valence shell, right? Well, this is a complete principal energy level. So if the atom gets small enough, and sodium's much bigger, so sodium would have a problem with that. We'll put it back. But sodium wants to get 8, but these other smaller ones, so let's take a look at beryllium here. So let's look here at beryllium. So if we find beryllium, I gotta clean this up, huh? Okay, so if we find beryllium, okay, oops. So here's beryllium. Beryllium is in what group? It's in group 2A. How many total electrons does it have? Well, it has an atomic number 4, so it has 4 total electrons. And how many of those electrons are valence? Well, it's in group 2, so it should have 2 valence electrons, right? Okay. What charge is the ion going to make? Well, it could gain, if it's at 2 and it wants to get to 8, it could gain, okay, let's count that. If we gained, right, if we gained 1 valence electron, that would be boron, so that would be, I'd be at 3. Then to carbon's 4, to nitrogen's 5, 6, 7, 8. So I had to gain 7 valence electrons to look like neon. That's a lot of work. Oh my gosh, doesn't sound like fun. But I only had 2 to start with. So the easier way to go would be to lose 1, look like lithium. And then lithium, if I lose 1 more, I would look like helium. So that's exactly what beryllium is going to do. It's not going to do this gain 7. That's just not going to happen. It's too much work. So the beryllium has 2 valence electrons. It's going to lose those 2 valence electrons. So if it loses 2, right, we started out and we had 2 valence electrons, right? Out of, how many did we have? Beryllium had 4. Let's do that. So we had 4 electrons total. We had 4 protons total. This is the atom. And we just said, what are we going to do here? We're going to lose our 2 valence electrons. So now we make the ion. So 4 minus 2, we're going to be left with 2 electrons and still 4 protons. So what's my charge of the ion going to be? Well, this is going to be beryllium 2 plus, because I have a positive 4 and a negative 2. That gives me a plus 2. So what's the charge on the ion? It's plus 2. So now, even though it doesn't have a complete octet, it does have a filled outer valence shell. So it's happy. It looks like a noble gas. Helium is a noble gas, even though it doesn't have 8 valence electrons. So that's the only time you need to kind of think outside of the box and remember that sometimes 2 is okay. All right. So now that we've kind of seen these patterns, let's try to add some things to our periodic table. See if I can erase. Maybe. Come on. Oh no. There it goes. Okay, so we're going to kind of erase a bunch of stuff. All right. So now, what I can do is I can zoom in on my periodic table. And this is what I really do recommend you write. Everybody in group 1, everybody has 1 valence electron. Cool. What are they going to do with that 1 valence electron? They are going to lose 1 valence electron. And so the ion will have a charge. Ion charge is always, always, always going to be plus 1. That's true for everybody in group 1A. Everybody. Move on to group 2. Group 2 has 2 valence electrons. It's going to lose 2 valence electrons. The alternative would be to gain 6. That's too much work. So the ion charge is going to be plus 2. Pretty easy, right? Okay, keep going, but don't worry about the transition metals. We're only talking about the main group elements. Okay, so group 3A is going to have 3 valence electrons. What's it going to do? Lose 3 or gain 5? Easier is lose our 3 valence electrons. So if it lost 3 valence electrons, now it's going to have a +3 charge, so a +3, okay? All right, group 4. Group 4 is weird. If we kind of come back over here to our table, I want to kind of look at the ones that are in, let's see if I can do this, that are in group 4A. So I'm going to kind of highlight them. Okay. 4A. These are our 2 that are in 4A, carbon and silicon. What I see here is that even though they have 4 valence electrons, you might think, okay, well, if I have 4, is it easier to lose 4 or to gain 4? Well, the answer is that's too much work. No matter how you cut it, gaining or losing 4 is too much work. So it's just not going to happen. Those things are not going to gain or lose electrons. Those elements in group 4A are going to share electrons. So no ions are formed. No ions formed. Okay? It's too much energy. The only other elements, I did that. Okay. So the only other elements that are not going to form ions are right here. See, none formed. Helium, neon, argon. What group are those in? Those are our noble gases. Our noble gases have 8 valence electrons. So why would they change? They have 8 valence electrons. They are super happy. No ions are formed because they have complete octets. So no ions formed. They don't create things with charges because they don't need to. Okay, so now let's take a look at group 5A. This is where we're going to make a change. So in group 5A, I have 5 valence electrons. So far, I've always lost electrons, but here's where I transition over and I have 5 valence electrons. It's a lot of work to lose 5 valence electrons. It's much easier to gain 3 valence electrons. So if I gain 3 valence electrons, what's going to end up happening is that I'm getting 3 things that are negatively charged, 3 more things that are negatively charged. Whatever element I was, like for example, if I were nitrogen, nitrogen has 7 protons and 7 electrons. It's going to gain 3 valence electrons because that's the easiest thing to do. If it gains and we turn it into the ion, what's going to happen? So it's going to gain 3 valence electrons. Now I'm going to have 10 total electrons, right? 8 of them are valence, 2 of them are inner. And I'm still going to have 7 protons. So if I've gained 3 valence electrons, how many more negative things do I have versus our positive? Well, I have 3 more negative things. So that is going to make a charge of -3. Then if I look at group 6A, it's following the same path. I'm running out of room here. I have 6 valence electrons here. What's going to happen is I'm going to, if I can kind of come up here, it is going to not lose 6. God, that's so hard. We're going to gain 2 valence electrons to get to that 8. If we gain 2 additional negatively charged particles, it's going to carry a charge of -2. So I hope you're seeing the pattern that's happening here. All right. Then our last one here is 7 valence electrons in anything in group 7A. So what is anything in group 7A going to do? Gosh, lose 7 or gain 1? Oh, so easy to just gain 1. Gain 1 valence electron. If it gains 1 valence electron, what's its charge? You have 1 additional negative charge compared to the positives, so it'll be a -1. So every time when you come into an exam, you're going to get a clean best friend, but this would be a good thing to keep around just kind of as you're studying and as you're working. Okay, So now that we have all these things kind of written up there, this is really going to help us. And I'm going to erase my stuff about nitrogen, right? We don't need that. Okay. So let's come down here. How many valence electrons are present in an atom of carbon? Well, all I have to do, oh, and I didn't write my number of valence electrons above group 4A. How many valence electrons do I have in group 4A? That's a great question. I have 4 valence electrons, right? Okay, so, because it's in 4A. So you have 4 valence electrons. In B, in an atom of fluorine. Here's fluorine. Fluorine's in 7A, so I have 7 valence electrons. How about oxygen? Oxygen is in 6A, so we have 6 valence electrons. An atom of silicon. So here, how many electrons do I have? I'm in group 4A, so that means I have 4 valence electrons. Okay, so are the atoms with the same number of valence electrons related? How does it keep going to sleep? Okay, so how are they related? Yes, they're related. They're definitely related. How are they related? So all atoms with the same number of valence electrons, are in the same group. And remember, groups are those vertical columns. Okay. So now, how many valence electrons are present in the following atoms? Chlorine. How many we got in chlorine? Let me see if I can erase this. Clean this up a little bit. All right. So chlorine. Here's chlorine. We're in group 7A, so we have 7 valence electrons. Then we come down and we say, okay, the next one's iodine. Well, it's in the same group, so it must have the same number of valence electrons, and that's 7. Coming on over to potassium here, K. K's in group 1, so it has 1 valence electron. Coming back over here, boron, group 3A, so it has 3 valence electrons. Nitrogen. Nitrogen's in group 5A, it has 5. Magnesium. Right here, 2A, 2 valence electrons. Argon. In group 18 or 8A, and all of those have 8 valence electrons. Neon is also in group 8A, so it also has 8 valence electrons. All right, stay tuned. Part 1, we'll have a part 2 and a part 3.